So in class 8, what we're going to see is we are going to discuss about force. How many of you have heard about force? I mean, I'm sure all of you might have heard about force. Can somebody tell me what is force? Can anyone tell me what is force?
Sir, force, right?
Yeah, force. What is force?
Sir, it's like a push or pull on like any object.
Force is like push or pull. Fine. Veda?
That causes motion or tries to change or changes the position of an object.
So it
or sometimes even changes the direction of an object in motion.
No, it sometimes changes direction of object in motion. Okay.
And even stops an object in motion.
Oh, it can even stop.
And also, sir, it can like also bend an object or even turn an object.
Change the form.
Okay.
Bend an object or turn the object, like change the properties of the object.
So it can change the properties of object. I'm hearing a lot of things. So let me try to make a note of all these things. So what do you say? You say force is push or a pull, right? Okay. So it's push or pull. That's what you said. And then what else? Changes position of object. That's what somebody said. Then what else did you say? Changes shape. Anything else? Can stop an object. What else? Can bend. Changing position, right? This is what you told. Let me try to make it a little larger.
And okay, also puts into motion and puts it to rest.
Yeah. Puts into motion and puts into rest. Okay, fine. So all of you gave me bits and pieces, like what is force. So let me try to take into consideration all your things and see, and express a few doubts from what you have told me. Now, so you said it changes something. Now, if it doesn't change anything, is it a force or it's not a force? Let's say I take something like, let's say I have an object like this, and I apply a force on this, right? So Arya, you can try your skills a little later. Fine. So let's say I apply a force on this. Now, what all things can happen to this body? It's placed on a surface.
It can move. It can be pushed.
So it can move when we push. Yes. Anything else? What else can happen?
Energy is transformed into the object. That's what I don't know. I'm not sure.
You're not sure. Okay, fine.
So there could be friction between the two objects.
As of now, we are not talking about friction. So if there is no friction, what else? It can move, right?
Its shape can be changed.
Yeah. If force is applied, is it necessary that it should move? If force is applied, is it necessary?
It's not necessary.
It's not necessary. So force is applied on a body, and can the body be still at rest?
Yeah. It's heavy, yes.
Just a second. I see people are exploring. Okay, fine. How to use the whiteboard.
It was an accident. I just was doing that.
That's okay. That's okay. No problem. Now let's see. So what all things a force is a push or a pull? That's for sure, right? What all things can a force do? A force can change the shape of the object, as you people said. A force can, put the body into motion. That's something else that it can do. A force can stop a body which is already in motion, right? That's also a force can do. What else it can do? And sometimes force might not do anything at all, right? Can you give me a situation where a force doesn't do anything? That means it doesn't change the shape.
When we're pushing against a wall.
Yeah.
When we are pushing against a wall, nothing is happening. Why is nothing happening in that case? Why is nothing happening when we are pushing against a wall?
Probably because the wall pushed from the other side is stronger than what you are pushing. I mean, like,
that's a good attempt.
There's not enough force for the wall for you to push the wall. Basic.
Okay, yeah, we'll be discussing that point very elaborately. I'll remind you again this definition that you told me, fine. So, because the wall doesn't push us with a great force, or the force from the wall is more than the force that we apply, what happens? The force doesn't move the object. That's what you want to say?
I mean, it matters what you're pushing the wall with. If it's a crane, it'll probably move. If
No,
it's
I'm saying,
you,
let's say you or I pushing the wall.
yeah, then it won't move because the amount of force you're using and the amount of force that you should use is very different.
Okay, so we'll get back to that. So that's not the only reason. We'll see why it doesn't move. Now the next thing. So we'll be discussing about that also. So the example that you gave is fine. One more thing, probably, there are two people pushing from two sides on an object and the object doesn't move. Is it possible?
If the force is equal, then
Yes. If the force is equal, it is possible, right? Is there any
Wait.
difference between you pushing a wall and two people pushing an object from both sides? Is there any difference between both of those
Yes,
things?
there is a difference because it matters if you both have, like, if both the, what do you call, both the forces are equal.
Okay,
The
I'll give you an
wall,
example.
the wall and you don't have equal force. You can't push it. But if you and your friend have different forces, then it's harder.
Okay, let's say this is something. Now you need to bear with me for a while because I'm not very good at writing with this pen. Anyhow, let's say a force F is applied from this side and a force F is applied from this side. So is this block, if it is already at rest, is it moving or not moving?
if
It
the
isn't
force is
moving.
equal, if the force
Yeah,
is equal, it's
F,
moving.
both are
The
equal.
force is the
F
same. They're both F. Yeah, it won't move at all.
move or don't move. So can I safely say it doesn't move, right? I'll say no, it doesn't move. I
It
think
doesn't move. Yeah, you're correct.
this is accepted. Now let me look at another situation. Probably that will help you to understand this better. Arjun, you can explore this later. Fine. And I'm sure this time it was not an accident.
Yeah, this wasn't.
Okay. So let's say I am trying to just draw it. So we have a box here and the box is, adjacent to a wall. Of course, I'm not able to draw it properly, but they're in contact. Now what I do is I apply a force on this like this. So I'm applying a force on this. I'm applying a force F on this. Now, is it moving or not moving? Is the block going to move or not move? I hope you understand the situation. The
Sir, it
situation.
depends
Not
on
going to
how
move
big
because the
and
wall
how heavy the wall
isn't going
is.
to move.
I'll say, can Arya give the answer? Yes, Arya.
It depends on how big the wall is. For example, if the wall is small, and then if it isn't that sturdy or heavy, you can just push through. But then, if it is,
Okay.
then you can't.
It's a normal wall of your house.
Okay,
And
then you can,
you can't.
unless
So you
unless
say
you're
you
Hulk.
can't. Okay, we are not Hulk. We are all normal people. Fine. So the answer from Arya is no, right? The body object would not move. And they also agrees to it. Veda, what about you? Veda, what do you want to say? Can you tell me what is the answer? Would the body move or no?
So it won't move because
It,
the force the force if you are pushing the box, the wall is applying the same amount of force, so the box won't move.
Not really the force.
okay, fine. Let's see. Let's see anyone else who want to say anything. So Ritu, so how many of you say that it wouldn't move? Let's have a quick poll and see. It's a simple thing, but still I want to, check. How many of you say it wouldn't move? If wouldn't move is yes. Sorry, it would move is yes, it wouldn't move is no. It would move is yes and it wouldn't move is no. There I know you have accidentally marked it, no problem. Others, it would move is yes and it wouldn't move is no. I want responses from Veda, Rishit, Shaumik, Ritu. Quick. Okay, all of you, almost all of you agree. Shaumik, what about your response? Shaumik, okay. So all of you agree that it's no. Shaumik, I'm waiting for your response. So it doesn't move. Agreed. Because we are not Hulks and the wall is strong enough, right? So now, what is the cause? Is there any difference between the upper block where there are two people applying two forces, and and the lower block where only one person is applying force on a block and the other side is touching the wall? Is there any difference between them? Yes or no? These two situations, is there any difference
Sure,
between?
I think yes.
Yes.
Yes. What is the difference?
So the difference is that since two forces are applying on that one block, so then the greater amount of force would push the block the other side. While here, how much ever you push the block, since we all are normal people, like how much ever you push the block, it won't move.
What is the reason why it is not moving? First part, it is very clear, right? Because there are two equal and opposite forces pushing an object. Net force acting on an object is 0, so it is not moving. The second case, we can experience that it doesn't move. But why is it not moving?
Is it because the wall is absorbing the force? It is able to withstand or absorb the force?
Okay, take it. Rishit, can you give me an answer for this? Rishit, Arjun, I want a reason for this. Why is it not moving? Because almost all of you told me that it's not moving. So why is it not moving?
Sir?
Because there's a wall blocking it and the force is not enough. If that wall wasn't there, it would move.
Okay, wall wasn't there, it would move. But the situation, so you want to say that if more force is applied, then it would move?
Yes, definitely.
Less, definitely. Okay, I'll get back to you. Kavya, you want to say something? Rishit.
Sir, because the force of the wall is more than the force we are applying.
Because the force of the wall is more than the force we are applying. Okay, so this was given by Rishit, right? Rishit, I'll again come back to you. Tomik, you didn't give me the answer for the previous one. Naisha, any answer from you? Veda, Naisha?
Yeah, I think I agree that the force that we're applying is comparatively lesser than the force applied by the. I mean, like it's not enough to move the object.
Okay, so it's very simple to say it's not enough to move the object. You answer, right? Okay, anyone else who want to say something? Fine, let me sum up all these things, all the things that you have told to me. Now, you would be surprised to know that there is absolutely no difference in physical sense between the two situations. The situation that's shown in the upper figure is almost identical to the situation that is shown in the lower figure in terms of. Now, why does that happen? Now, see, what is happening here is, you all know that there is a force that is applied here. Here, two equal forces are acting. Now, I'm applying a force F on this. What is happening? The wall is also applying a force F on this in opposite direction. The wall is also applying a force F in opposite direction. That's why the block is not moving. I hope you understood that. So in the first case, there are two people applying forces in opposite direction. The second case, I am pushing the wall through the block. The wall says, I also want to push you with the same force. And one more important thing is, if I'm pushing with X units of force, wall will also push you with X units of force. Wall can never push you with a force greater than that. I hope it is clear. Got it?
Yes, got it, sir.
Yes. So both the cases, what is happening? The net force is 0. So one more. Yeah. Any doubt in this to anyone? So if I keep on increasing the force applied on the wall will also keep on increasing the force applied. That's why, if you're one person, you call your friend and say, let's push it together. Even then it doesn't move unless and until you call Hulk and say, come on, help me out. So what is happening?
Or sure, like what if one person has a greater strength than the other? It would move.
No, but we are saying that equal forces are applied.
Okay, and if equal force is applied in both, then it's the same scenario as
so
the
first case, it is equal forces are applied. Second case, what is happening? Whatever force you, your friend, and your team are applying on the block, the same force wall is also applying on the block.
But then, sir, what about the cases in cranes, when the cranes hit the wall? Why doesn't it hit the wall?
I'll explain it to you, right? So instead of taking a wall as a reference, I'll take something. Let's say your car is there, right? You parked your car and you take a small block and push the block against your car from behind, right? So what will happen? The block will stay there because the car is also pushing or applying the same force. What I want to say is, let's say this part is the rear of your car instead of wall. Fine. This part is rear of your car. Now you're pushing, this will also pull. You know what happened? You call a couple of friends. What will happen after that? The car starts moving. That means what? The car can apply a force in backward direction only up to a certain level. Like, you know, I'll say in terms of forces, let's say you apply X unit of force, the wall is applying X unit of force. You're applying 5X, wall is applying 5X. You're applying 10X, wall is applying 10X. But if wall cannot withstand a force of more than 15X and you apply 16X, what will happen? The wall will break and the box. I hope you're understanding it.
Yeah, I can.
Yes?
Yes,
Yeah,
sir.
it is something like your friend pushing you. He pushes slowly, you don't move. Why are you not moving? Because you're also pushing him slowly. He increases your force, you still don't move. Why? Because you're also pushing with the same force. He calls a couple of friends of him and all of them push on you, you move. Why do you move? Because there is a maximum limit of force that you can apply on him. You can't apply more force than that. Yeah, it's something less. So one important thing that I can say is, if a net force is acting on the body, then the body would definitely start moving if it is at rest, or it might stop its motion if it is moving, or its velocity would change. I hope it is clear. If a net force is acting on a body, what will happen? It will definitely change the velocity of the body. So what are the ways in which velocity of a body can be changed? If it is rest, it can be set into motion. If it is moving, its speed can be increased. Got it? Or its speed can be decreased. And if it is moving, its direction of motion can be changed. I hope it is clear. All of you? All of you, is that clear?
Yes,
So,
sir. Yes.
Yes,
now,
sir.
now let's, scribble down these things on your books. You can just quickly scribble down these things. I'll just type it here in the chat box. The first thing, what is a force? A force is, I'll keep it very force. I assume that the objects that I'm taking are not the objects whose dimensions are very small. We'll not talk about objects which are having shape. If the object is having shape, then the force can change the shape of the object. So a force can, a force applied on a point object. What does it do? Force applied on a point object can, what all things it can do? Set the body into motion from rest, right? To stop the body which is already in motion, and stop the body which is already in motion. 3, and slow down or speed up. Or what else it can do? Change the direction of it. And 4 points on that. What all things it can do? It can set the body into motion from rest. It can stop the body which is already in motion. It can slow down or speed up the body in motion, or change the direction of motion. I hope that's clear to all of you. Yes, Kirtana, I'm not taking into consideration change in shape of the object, because I'm considering objects which are very small. So we are considering objects which are very small. If the objects are very small, the change in shape of the object can be neglected. So I'm taking point objects. What are point objects? Objects whose dimensions are very small compared to the dimensions that it is moving. Then we say the objects are point objects. I hope it is clear to all of you. So all
Yes,
this,
sir.
yeah, all this together, I can say what is, it can be put together, and it can be stated that a force, I don't say can, force changes the velocity of a body. All the points together can be said as a force changes the velocity of a body. If a force is applied, then the velocity of the body will definitely be changed. That's clear? Got it? Because when I say velocity, it has direction. If its direction is changing, velocity is changing. If a body is at rest, it starts moving, its velocity is changing. If a body is moving, it's speeding up or it is slowing down. In both the cases, what is happening? Velocity is changing. I hope that's clear to all of you.